Good afternoon, everyone. Welcome to SPREE seminar. And today we have Dan Liu from TUV Rheinland. Yeah. And as we move towards net zero, all different countries put a certain requirement on the carbon emission of the products that includes our solar panels. So Dan works at TUV. Her work major involves in life cycle assessment, carbon footprint certification, and EPD, environmental product declaration. So in today's seminar, Dan will talk about how do we do the certification, the accreditation, and what are the standards that all our solar panels need to meet in this latest sustainable era. And she is project manager at TUV Rheinland, and before she started her job, she actually finished her photovoltaic and a master of photovoltaic engineering here at UNSW in 2018. Let's welcome Dan.
Thank you. Yeah. Thanks for the invitation, Ron. And hi, everyone. This is Dan from TUV Rheinland, Shanghai. And 5 years ago, in 2018, I'm a graduate UNSW student. And now I'm a project manager in TUV Rheinland, who is responsible for the carbon services. As Ron introduced, we have the carbon services of life cycle assessment and environmental production declaration, and we also do the carbon footprint evaluation for the PV modules. And it's my great honor to be here to give this presentation, and I hope that everyone here can have a better understanding of what the LCA can be used in the PV industry. And so today my content will be this 4 main parts. One is background and LCA, and then we can say what the LCA can be used in the industry when the PV manufacturers they would like to export their products to overseas countries. They need LCA report or carbon footprint report. So part 3, life cycle assessment applications, we will have the specific services of TUV Rheinland. And the final part is that we can do more based on LCA. So for the background, when we're talking about the life cycle assessment, talking about the LCA, the first background, that should be the environmental problem. We can see that the biodiversity loss caused by the wetland degradation, deforestation, and wildlife extinction, with more and more serious environmental problem happening, and people began to aware that it's time to be more environmental friendly. And so we can see that the majority of the environmental problem may caused by the human consumption and production activities. So here we need a method to quantify what exact the potential environmental effects caused by the human consumption, and we need a method to quantify the exact potential environmental impacts. So that is LCA can do, and LCA is emerging and be paid more and more attention to the product system or product's life cycle. And so that's one of the background is more and more serious environmentally problem. And another background, as Ron introduced, that is the policy orientation. We can see that with more countries to set their dual carbon policies and net zero target, and the countries or the government try to improve the public awareness of environment protection. And we can see they set the net zero target in law, in policy document, and also in the declaration, or some governments are planning to set their net zero target. So that is another trend to guide the public to be more environmentally friendly. And that's another background for life cycle assessment. LCA is becoming more popular. And that's part 1 about the background of LCA. And then we we can say, so what is LCA? So students from UNSW can learn about this from Ron's class, of course, but other people can also learn about this from the standard. We can say that the standard series of the International Standard Organization, the 14000 standard series, 14040 and 14044, when we do LCA projects, we mainly refer to these two standard 14040 and 14044. And 14044 set the principles and framework of LCA, and the 14044 set the specific requirements and the guidelines when we do LCA project. So people can find the definition in the standard. So what is life cycle assessment? You guys can see it on the slide, which is compilation and evaluation of the inputs and outputs of the potential environmental impacts of a product system throughout its life cycle. So here we understand that life cycle assessment is a method. As I mentioned in the background, it can quantify what the exact potential environmental impacts of a product system. The product system here can be a real product like the table, the chair, but it can also be an activity, an organization. So don't limit the product or product system to the real stuff. And that is what is LCA and what LCA can be done. There are two main standards that we can refer to. And we can also say that there are more popular environmental labels or environmental declarations can be found in our daily life. And the International Standard Organization also set the specific standards to regulate the people how to operate the environmental labels and environmental declarations. And if anyone is interested in the environmental labels as shown on the screen, you can search for this standard series. They are ISO 14020 standard series for the environmental labels and environmental declarations. So that is the standard for life cycle assessment. And before we do a life cycle assessment, I'm pretty sure that the students here already have a better understanding of these words. What is the life cycle and what is the functional unit, system boundary, and reference flow? So, but for in reality, for the PV industry, what is the functional unit that we usually use in the LCA project? There are mainly two functional units. One is 1 kilowatt peak, DC power generated from PV or generated from solar panel. Another one is 1 kilowatt hour DC electricity generated from PV plant. So that's two main functional units when we do the LCA projects in reality. And for the system boundary, we know the cradle to grave or cradle to the gate. But for the PV industry, when we're talking about the system boundary, cradle to the gate means from the raw material acquisition to the PV module manufacturing. And from another system boundary, which is cradle to the grave, means from the raw material acquisition to the final disposal, even including the recycle of the PV panel. So that's the main two system boundaries when we do life cycle assessment projects in reality. And the reference flow, as you know, and LCI, LCIA, and life cycle interpretation, we will explain this in the following slides. And the impact categories, yes, there are 14 impact categories which can be divided into 3 main categories, and we will explain this later. And the product system, as I explained in last slide, that the product system is not only limited to the real stuff, it can be an organization, an activity, or even a service. So that's the definition of product system. So before we do the life cycle assessment, we do the LCA, we need to understand, or even we need to try to set some examples to help you have a better understanding of these words. So that is the definition. And we know that the standard 14044 set the specific requirements and guidelines of LCA. So the methodological framework of LCA could be this one. The screen shows there are main 4 steps. Step 1 is goal and scope definition, and followed by LCI, life cycle inventory analysis, and then step 3, life cycle impact category assessment, and then life cycle interpretation. We also call it life cycle report. So the direct application when we do LCA can be the product development and improvement, and it can also be used to do the strategy planning or public policy making, or even the marketing. So the direct application is derived from the first step. What is the goal and the scope definition of the customer? That is quite important one way to meet the customer to say when the customer began to consult, they are going to do a LCA project. So we ask the customer firstly, what are you going to use the LCA report to do? What's the purpose that you are doing LCA? So that is the goal definition, and it determines the functional flow, also determines the system boundary and the reference flow that we are going to use in the LCA project. So the customer may use the purpose of customer doing LCA may be used for marketing, or for improve their reputation in the market, or to do the public policy making, or to do the to upgrade their energy system. So for different purpose, we set different system boundary for the project. And that's quite important for the first step, to make sure you understand what's the customer's purpose when they do LCA. For the first step, goal and scope definition. And then that step 2 is LCI, we call life cycle inventory analysis. So that needs the quite cooperation between the TUV Rheinland and the customer. The customer need to do the data collection to provide the real data as possible, like the manufacturing data, the raw material data, and even the waste energy usage data. And then we use the TUV Rheinland use the software, Gabi or SimaPro. As usually we do the simulation and the modeling for the customer based on the data they provided, or even we use the data from the database. And we got the result, we move to step 3, life cycle impact categories. And as I said before, there are 14 impact categories divided into 3 main categories: natural resources, natural environment, and human health. And here we say that when we're talking about the carbon footprint evaluation or carbon footprint assessment for the product, there is only one impact categories will be used, which is climate change. But for when we do the LCA, do the life cycle assessment, we need to evaluate the total 14 impact categories. So that's the difference between carbon footprint evaluation and life cycle assessment. And that's the difference, and be quite sure about this, because the customer always confused with the carbon footprint or LCA. And here is the example here to explain the quantification. So when we're talking about the LCA result, firstly, we specify which impact categories that you are going to say. So you can see that with the climate change, the LCD-TV is better than the CRT-TV. But when we're talking about the resource depletion, the CRT-TV is better. So here you cannot, when we're talking about the LCA result, you cannot just simply to say that LCD-TV is better than CRT-TV. No, that's wrong. So we need to specify the impact category first, and then we're talking about the result. So that's the reason why we use impact categories to do the qualification. And you guys can also find that the total result can be used in the number, in the number to show the exact potential environmental impact of the product system. And that's about the step 3, life cycle impact assessment. And you may ask, after understanding the methodological framework of LCA, so what LCA is used in the PV industry, in the PV manufacturing? We know that China shares the most market in the PV module and in the production volume along the solar value chain. And here we do most TUV Rheinland do most LCA projects for PV manufacturers when they doing the solar cell manufacturing and the PV module manufacturing. So this is the real LCA project plan for the PV manufacturers. So mainly 2 parts. One is certification process, another one is a certificate part. So in the first part, there can be divided into 3 stages. One is project setup, that is for the sales part. And then we need to have a technical training to the customer to explain how to do the data collection, what exact data that the customer need to collect from their base, their manufacturing site. And then the third part is LCA. So in part 3, which is quite important, we need the leading part of the client, of the customer. They need to lead the data collection part. They need to transfer that what exact data from data requirements from TUV Rheinland to their different department in the manufacturing base. So for part 1 certification process, there are 3 main parts, but the most important part is in part 3. And in part 3, when we do LCA and stage 2 data collection is quite important for the customer to leading this. And so after we get the data from the customer, we do the modeling and simulation, we get the result, we prepare the life cycle assessment report for the customer. And then we need almost 2 weeks to prepare the LCA report and LCA certificate for the customer. And you guys can also have a look what the exact certificate that TUV Rheinland can give to the customer. So I said that in LCA part, the step 2, LCI, life cycle inventory analysis is quite important for the customer, and we need customers' cooperation to do the data collection. So for most PV manufacturers, except for the giant, country like Jinko and China, they have the whole value chain of their product system. But for most PV manufacturers, they can only provide the real data of solar cell manufacturing and PV module manufacturing. And here comes the one problem about system boundary. If they don't have the real data about polysilicon manufacturing, ingot or wafer manufacturing, what would they do? One of the solutions is that they contact their supplier to ask for the cooperation to support them to provide the real data. That's one of the solutions. And otherwise, we can use the data from the database in the software. That's another solution for that. And usually when people, the manufacturers is asking to provide more and more LCA reports currently, and more PV manufacturers to ask for their suppliers to prepare the LCA report or the carbon footprint report for their wafer, the ingot, and more. We can say upstream manufacturers began to do LCA and to do carbon footprint evaluation of their product. So that's a good trend and good news for the for the company in the downstream to begin to use the data from the upstream, and that is good due to the policy orientation. And another problem caused by this is the system boundary. We know that if people do a project an LCA project with system boundary of from cradle to grave, we need the data from the PV panel usage stage, like PV panel be used in the solar farm. But we know that PV manufacturers, they do LCA project for their new product series. So the new product haven't been used in the PV plant. So what's the data of the usage stage can be provided? Here, in reality, we may use the PV to do a simulation, including the construction or even the recycling. So that is what we have done. In reality, we cannot get the real data from the PV plant currently. And yeah, so that's the difference of theoretical and the reality. And so we talk much about data collection. You may be interested in what exact data that the customer need to provide. Here is the explanation to this, and that is the data collection for TUV Rheinland. Different consultant agencies have the different method, but for TUV Rheinland, we collect data mainly for these 3 stages. One is the material stage, and the manufacturing process of the ingot solar cell PV module, or we need the relevant evidence to support the data that they provided. So for material stage, we need the data of the raw material input. And we know that for the PV module, there are 7 or 8 main components, like the frame, the glass, and EVA, POE, or solar cell, and the backsheet or the junction box. So we need the input flow of the raw material. And then we also need to collect the data of the auxiliary material, packaging material, and residues and transportation. So here is the question, do we need to collect every data that the customer has recorded? The answer is no. We use the cut-off rules here according to the weight texture. For if which means the packaging, like the packaging material takes quite little amount of the weight of the product, we don't need to collect them. We make an assumption based on the cut-off rules. I think Ru may explain the cut-off rules in class. Yeah, and that can be used here in reality. We also use cut-off rules here when we do the data collection. And the main data, except for the material stage, other main data we collected is energy consumption. Here may be the the electricity, water, and gas which are used in the manufacturing base. We collect the real data. And the supporting evidence or relevant evidence is the monthly or the quarter electricity or water bills. To support this, we also ask the customer to provide the bills to support this data part. And yeah, so that's in manufacturing process. In China, there are some gas emission or greenhouse gases emission controller in our monitoring system in the manufacturing or in the factory. So we need the customer to provide the annual report of the greenhouse gases emissions from the government. So that's another data collection for the manufacturing process. And the relevant evidence, as I mentioned, the bills, electricity, water, and gas bills, or the summary of waste generation demonstration. Here, I think in chemical in the chemical requirement in China that the factory need to provide the chemical disposal annual report. So we also can find the data in this supporting file to find what the annual waste that the factory can generate, and then we get the data for the time period that we want. So that is what the real data that we want customer to provide. And we also to track the relevant evidence to support their data. And here another is one point should be emphasized is the data period. And when we do LCA, we ask the customer to provide the data for the past at least 6 months. So that's the reason why we have a valid date for the TUV Rheinland certificate, almost 2 years for TUV Rheinland certificate. But when we do the EPD application, the valid date will be almost 5 years. Because during, so 2 years or 5 years is quite enough for the PV manufacturers to upgrade their product series. During in the future, the customer may upgrade their energy system, for example, to adding the PV modules in their factory, or they may change their market trend. They may don't need the product series currently. They may produce other, technology. We know the PERC before, but here TOPCon. So different technologies, different products may come in. So 2 years or 5 years valid date determines the data period for data collection is quite important when we do LCA project. We need to emphasize this when we do the project, and the customer should be aware of this. And so we went to Rheinland to do LCA project. What the customer finally can get. Here is one of the certificate that we do for the customer. I have display this here, and you guys can say we display the system boundary here, and data period, function unit, and we also to display the analysis method here, because this information is the basic or preliminary information when we do the LCA. So as I mentioned, the data is the certificate is valid for 2 years only for this certificate, which means 2 years later the certificate is invalid. So that is because the supporting data is the currently supporting data, and we don't show the data, the raw data on the certificate. We only give the result here. You guys can say that the impact category for LCA projects, there are 14 impact category results, but when we do the carbon footprint evaluation, we can only show the global warming results here in the number. So that's the real certificate that the customer can get from TUV Rheinland when they pay to do the LCA project, and to be realized that this preliminary information is quite important, and it can from the beginning to the end of the project, everyone in the project should be aware of this, because for each project, this information may be different. And that is the result of LCA. And here is a question. When we're talking about the impact contribution, what's the dominant life cycle stage? Take the dominant, impact contribution to in the manufacturing, and the answer is polysilicon production. And people may think that PV manufacturing stage is the dominant contribution to the impact environmental environmental effect, but that is wrong. Because in the polysilicon production, there are so huge fossil fuels is used to, as the energy to produce the polysilicon. Though that may be, a little difference to the public awareness, and yeah. And that's the part 2 about LCA. We explain that from the standards, definitions, and different stages, and in the reality, what we have TUV Rheinland have done for the customer. And the part 3 may be quite popular for the people to aware, including the eco label or the environmental declarations or some real services that can represent the environmental trend around the world. So should we have a 5-minute break, Ron? No? Okay. So in LCA applications, so except for TUV Rheinland can provide the LCA service, can do the LCA project for the customer, what the real strategy or the real policies that foreign countries ask our customer to do. In this part 3, I will explain the popular services that for the main countries they are asked for. So the first one is product carbon footprint requirement. And you can see that is the marketing demand from the France. And the French government to say any PV manufacturers need to provide the production carbon footprint report for their PV modules if they want to bid any PV projects over 100 kilowatt, which means that the customer need to do the carbon footprint evaluation if they want to extend their product in France. And so now it's quite popular for the PV manufacturers prepare their carbon footprint report for their new product series, and that is called ECS report, and it's operated by the whole program is operated by the French government, and the evaluation is by 30 Solis. And we, TUV Rheinland, also can provide this service to the customer. We can prepare the ECS report for the PV manufacturers based on the requirements from the 30 Solis. And that is one of the popular service that PV manufacturers need to keep an eye on. That is the France carbon footprint requirement. And another service that is the environmental production declaration. We also called it Type 3 environmental product declaration. And when we talking about the declaration, except for the ISO 14040 or 14044 standard series, here is another standard, which is 14025. This standards to regulate the EPD program, to ask them to show how will they prepare the PCRs, how would they regulate their whole program to make their label or to publish the information of the applicants. So except for the ISO standards, there is another important file here, which is called product category rules. The product category rules is specific based on different products, and it is can make a comparison between different products which have the same function by citing the default parameters. For example, the PCR of the PV modules of EPD Italy, they set the same system boundary, they set the same functional unit, and every applicant use the same method based on life cycle assessment, based on the same system boundary to do the EPD application. And by audit the different results coming from the same method, and they publish the results on their website. So that is the EPD application services. And there are three popular markets for EPD. One is EPD Italy, EPD Norway, and EPD International. That's the three main markets for the PV manufacturers to apply currently. And when TUV Rheinland to do the EPD application, the service flow is as the screen shows. There are 5 steps. First step, the TUV Rheinland to explain the product category rules for the customer to make sure the customer understand what the exact requirements from the EPD program. And then we do the LCA part, and which needs the TUV Rheinland and the client to cooperation, like the data correction and software modeling and simulation. And that is step 2. And then TUV Rheinland to prepare the EPD report for the customer. And then customer take the EPD report to submit the report to the EPD Italy. And then EPD Italy to audit the EPD report. Here should be some data in the EPD report. So in the audit part, the EPD Italy will ask for the relevant evidence to support the data. After the audit process, and the EPD Italy would publish all the information of the LCA and EPD report in their website. So that is the whole service flow for the EPD Italy registration or EPD Italy application. And the final deliverables for the customer when they pay for the EPD services will be this: for they can get the LCA report and also EPD report, and they also can get the tool mark for free because they already paid for the EPD services, so the tool mark will be free for them, and they also can get the published EPD information. And for example, on the right side of the screen is the EPD program that we done for Genco, and it is shown that the valid date is 5 years, but that may quite small. You can see that the valid date for EPD application is 5 years, and the manufacturing base is 3 base to be included in this EPD report, that Chuzhou, Haining, and Yiwu, which means these 3 manufacturing sites, they provide the real data in the EPD application. And also the product series can also be found on the first page of this EPD report. And that is the EPD Italy, for example, as a representative service to explain how to do the EPD application. And that's another popular service to do the EPD application. And the third trend that from the European Commission has already gained the PV industry contribution, which is eco-design and energy label. We can say that last year, in the March of last year, and the European Commission set the working plan for the eco-design and energy label of energy-related products. We can say that the eco-design is to include the solar panel as the new energy-related product to their working plan, which means the solar panel that going to export to the European market, they also need to meet the eco-design requirement and energy label. And in the working plan, we can say that the ask for the energy efficiency and material efficiency and carbon footprint. But the energy efficiency and material efficiency have already done for the most PV manufacturers currently, and they added the carbon footprint requirement. And we can say that they ask for the PV manufacturers to provide the carbon footprint report, and to say their for the polycrystalline modules, their carbon footprint emissions should be less than 25 gram carbon dioxide equalization per kilowatt hour. And for the monocrystalline modules, the number should be less than 18. And all the evaluation or assessment method should be based on the PFCR. So that is the plan, and that is the working plan for the coming from the European Commission about the eco-design of PV modules. And another requirement is the energy label. The energy label citing the energy rating for the PV modules from A to G, which is 7 classes for the PV modules. As we can say the energy label in our daily life, we can say the refrigerator, the energy label may be in the refrigerator, in the air conditioning, or even in the TV to show how much the environmentally friendly of the electrical products. But here the European Commission to set the energy label requirement for the PV module. And like for the QR code or name trademark, that requirement is quite normal. But we can say that there are three information are derived from the energy efficiency, which is a requirement for energy efficiency class from A to G, and the calculation need to based on IEC standard, which is 61853 standard series. There are the calculation or the simulation method in the standard we can find. And it is under 3 climate conditions, and we get the result of the PV modules, the generation result of the PV modules under these 3 climate conditions. Different number refer to different classes. So that is the energy label requirement of the PV module asked for the European Commission. And you may ask what the exact date of this regulation will be work. They said next year, but we will keep an eye on this and to to be aware of the exact details of the whole regulation. But we can find that in this working plan, the information is all about to make our PV module to be more environmentally friendly, to reduce the greenhouse gases emissions during the manufacturing process. So that is the quite popular policy made by the European Commission, eco-design and energy label. Yeah, we talk about the environmental declaration, we talk about the eco-design. Now here comes to the eco-label. That is the eco-label from the America, the US, and EPIT. We also call this Type 1 eco-label because it's operated by the GEC, the Global Electronics Council of the America. And they cite there are 7 product categories in the EPIT application, and one is PV module and PV inverters. And they have the exact standard when people apply for the EPIT eco-label. That is ANSI 457, which is 2019 version. And in this standard, we say that life cycle assessment is one of the required clause for the people need to do. And people apply for the EPIT. There are bronze and silver and golden. By meet the basic required clause, 16 clause actually, and by meet the different number of optional colors, people can get the bronze, silver, and golden EPIT eco label. And quite important one is that as the clause 7, which is life cycle assessment, there is one required clause for the applicants, which means the applicants have to do the LCA for their product when they do the EPIT application. Yeah, that is eco label for eco label of EPIT. And except for this, I have introduced the most governmental programs. There are some other unions that people can also disclaim their product information, like the CDP, SBTI, and their international organizations. You can also to join them to meet their requirement and to display your product information and to show that your product is more environmentally friendly. And these international organizations can also be the best way for you to display them and to promote your product. Yeah, and that is the eco label for the Australia. And I never said this in Australia before, but if you meet this, you can say, oh, that is one of the eco label of Australia. And yeah, part 4, we can do more. So there are some strategies to promote the greenhouse gases reduction and absorption. And we can do more when we do the animal, improve the technologies in the animal like production. And we can do the revolutionary technologies in this, like to improve the manufacturing efficiency, or to add more PV panel systems to make your power or electricity system to be more green. That is we can do more. And yes, carbon dioxide capture and utilization and storage. The source of the carbon dioxide from biomass, fossil fuels, and air can be captured and to be stored in the ocean side. So that is the revolutionary technologies in future that we can do more to reduce the greenhouse gases emissions. So that's what I want to share with you guys about the LCA, and I think that's all. And if you guys have any question here, you can ask. And here is my email address. Just send the email if you have any question or any suggestion. And any questions, guys? Yeah.
Yeah. Hi. Sorry. So for collecting data on electricity, water, gas, and waste, how do you disaggregate the impacts to a certain product line?
How what?
Because you get the data for a whole factory, I
Yeah.
guess. How do you allocate the impacts to a certain product line?
Yeah, good question. Because in the manufacturing base, the electricity meters they are not assembled. They are for the big factory, the different manufacturing rooms are be divided by the electricity meter, and so the electricity bills can be divided by the meters, not the allocated. So that's the reason we check the bills to recheck the data the customer provided. Any other question? Yeah.
Actually, I have a question. So in the LC application, you explained that companies need to get all different certificate and label to
Yep.
enter a foreign market. Is there any example that the manufacturer, after they get the result, they actually try to use it to improve their internal design?
Yeah.
Is that one of the applications?
Yeah, but they now actually they may use the application to promote in the marketing, but for the internal upgrade or internal strategy planning, they may not use the foreign and eco labels or declaration requirement. There are some but only for the energy system usage upgrade. But for the their internal technology upgrade, that may be only the that may only the suggestions, not the main dominant reason for the customer actually. But that could be help the customer as evidence to show them to which manufacturing process may have more greenhouse gas emissions, and they can make the energy upgrade and to reduce that emission. Yeah.
Any other question in the room?
Yep.
So how much uncertainty is there in sourcing data from suppliers?
How much?
I mean, in terms of the whole carbon footprint, would there be a large uncertainty because you would have to ask from the company suppliers or the suppliers of the suppliers?
Yes. So you mean the suppliers will ask their suppliers to help and to support to provide the real data? Yeah, that's the problem. Yeah, that's the real problem when we do the LCA projects. We're facing most PV manufacturers. The PV manufacturers can ask the help from their supplier, like the wafer provider. But for the polysilicon or the ingot manufacturer, would they help their downstream customer to do that? The answer may be not. But for the TUV Rheinland, we will not negotiate the relationship between, we don't do that. But if they would like to help, as I mentioned before, due to the policy orientation, the upstream providers, they would like to do this. They would like to do this by themselves because they got the data. And when more and more customers ask for this, they can provide directly. So that's the power of the policy orientation, and that's the trend. And if they have the carbon footprint report, they will be more competitive in the market. Cause you have and I don't have, and the customer asks for one, but you have, you can give it direct. I don't have, no, not you. Yeah.
Any other questions? Well, if not, let's give a round of applause again.
Yeah. Thank you guys. Thanks for your time.